Welcome students to the lecture number 5 of Computer System Architecture. My name is Rajiv Sharma. I am working as Assistant Professor Computer Application in Siddharth Government College, Nadon. Students, the main objective of this lecture is to understand the complements. Students, let's start our discussion with the understanding what are the uses of the complements in computer. Students, as we have discussed in the logic gates that complement and logical NOT operation are equivalent to each other. So the complements are used to implement logical manipulations. Apart from this, the complements are used for the simplification of the subtraction operation in computer. Students, now let's discuss what are the various types of complements. Students, for any number which have base equal to r, we have two types of complements, r's complement and r minus 1's complement. In the previous lectures, we have understood that various number systems. We have learned that there are four type of number systems that we use in computer. The first one is decimal, second one is binary, third one is octal, and the fourth one is hexadecimal. And the base values in these number system are 10, 2, 8, and 16 respectively. And therefore, for decimal number system which has base 10, we have two complements, which is 9's complement and 10's complement. For binary number, we have two complements, 1's complement and 2's complement. For octal number system, we have two complements, 7's complement and 8's complement. For hexadecimal number system, we have two complements, which are 15's complement and 16's complement. Students, now let's understand how we can find r minus 1's complement of a number. To find r minus 1's complement of any number n, which has n digit and base equal to r, the formula is small r raised to the power small n minus 1 minus n. Students, in this case, r represents the base of a number, small n represents the number of digits, and the n represents the number itself. We can understand this with the help of example. Students, in example number 1, we want to find out the 9's complement of the decimal number 29. So in this case, the value of n is 29, value of r is 10, which is equal to the base of the decimal number system, and value of small n is 2, which is equal to the number of digits in the given number. So we have two digits, 2 and 9, so value of small n is 2 here. Students, when we put these values in the formula, we will get 10 raised to the power 2 minus 1 minus 29, and after simplification we will get 100 minus 1 minus 29, and which in the next step will become 99 minus 29, and finally we will get 70 in the answer. Students, we also have a shortcut for finding the 9's complement of any number. In this case, we will write 9's equal to the number of times the digits contain that number, and after that we will subtract the given number with that number. For example, in this case, we have two digits, so we will write 9 twice, so we'll get 99, and after that we will subtract the given number, that is 29, from 99, and after that we will obtain 70, which is the 9's complement of 29. So in this way you can easily find out the 9's complement of any decimal number in a very quick manner. Students, let's take another example. In this case, we'll find 1's complement of a binary number. So in this case, the number is 101. You can see that we have written base as 2, and to indicate that it is in binary. Student, in this case, the value of n is 101, or which is equal to the decimal number 5. Here value of r is 2, which is equal to the binary base, and here the value of small n is 3, because number of digits in this case is 3. Students, we will put these values in the formula, so we will get 2 raised to the power 3 minus 1 minus 5, and after simplification we know that 2 raised to the power 3 is 8, so the equation will become 8 minus 1 minus 5, and which will finally become 2, and after that we will change 2 into its binary form, which is 0 1 0, which is the 1's complement of 101. Student, we can also find out the 1's complement by using shortcut. the shortcut to find ones complement is very easy. In this case, you will change the ones to zeros and zeros to ones. So the ones complement of 101 is 010. Students, let's now understand how to find r's complement of a number. Students, the r's complement of a number which has n digits and base r is equal to r minus 1's complement plus 1, which is further equal to r is to the power n minus 1 minus n plus 1, and which finally become r is to the power n minus 1. For example, the tens complement of a number is equal to its 9 complement plus 1. Similarly, the twos complement of any number is equal to its ones complement plus 1. Students, now let's take examples to understand this concept in a better way. In example number 1, we want to find the tens complement of number 29. In this case, the value of n is 29, and value of r, which represent the base, is 10, and the value of small n, which represent the number of digits in that number, is 2. So we will put these values in the equation r is to the power small n minus n, and we will get 10 is to the power 2 minus 29, and which in the next step will become 100 minus 29, and we will finally get 71. Students, we can also use the shortcut to obtain the tens complement, and the shortcut is keep the rightmost zeros as it is, and subtract the first non-zero digit by 10, and subtract the rest of the digits by 9. Students, in our example, the number is 29, and we do not have zeros on the right hand side, so our first digit on the right hand side is a non-zero number, so we will subtract this number uh, from 10, and we'll get 1 in this case, and we will subtract the rest of the digits, which is 2 here only, so we'll subtract 2 from 9, and we'll get 7. So finally we'll get 71, which is the tens complement of 29. Students, let's now take another example. In this case, we want to find 2's complement of 101. Student, in this case, n is 101, which is equal to 5 in decimal, where value of r is 2, which represent the binary ways, and the value of n is 3, which is equal to the number of digits in this number. Student, in this case, we will put these values in the formula, so we will get 2 raised to the power 3 minus 5. 2 raised to the 3 is 8, and 8 minus 5 is 3, and after that we will change the uh, result into a binary number, and we will get 110. And here we can see that number of digits in the result and the number of digits in the question are same. Students, we can also use the shortcut to find the two's complement. The shortcut is keep the rightmost zeros and as it is, and the first one unchanged, and change the rest of the digits from ones to zeros and from zeros to ones. Students, in our example, the number is 101. We do not have zeros on the right hand side here. Our first digit on the right hand side is 1, and according to rule we will keep the first one unchanged, and we will keep this one as it is, and after that we will change zeros to ones and ones to zeros, so we will get 110 in the result, which is the two's complement of the number 101. Students, let's now take a few more examples to understand the concept of complements. Here we have taken two questions, and in these questions we have to find 9's and 10 complement. In question number 1, the number is 452. So in this case we know that value of r is 10, value of small n is 3, and the value of the capital N is 452. We will put these values in the formula, and we'll get 10 raised to the power 3 minus 1 minus 452, which in the next step will become 999 minus 452, and finally we'll get 547. Students, we know that we can solve this with shortcut also. We will subtract this number 452 from 999, because number of digits in this case is 3, so we will write 9 thrice, and after that we will subtract 452 from 999, and we will get the 547 in the result. Students, in the tens complement, we will put the values of small n, r, and capital N in the formula r raised to the power n minus n, and we will get, in this case, we will get 1000 minus 452, and finally we'll get 548. And students, we can use shortcut here also, and you know that in the shortcut we will subtract the first non-zero digit from 10, and in this case it is 2, so we'll subtract 2 from 10, we'll get 8, and after that we will subtract rest of the digits from 9. Our first digit is 5, we will subtract 5 from 9, we will get 4, and we'll subtract 9 from we'll subtract 4 from 9, and we'll get 5. So in this case we'll get 548, which is the tens complement of 452. Students, you can solve the second question by yourself. Students, now let's take the examples to find ones and twos complement. In this case we have taken two examples, A and B. I will discuss the question number B here. You will solve question number A by yourself. In question number B, the number is 1100111. In this case, the value of small n is 7, value of r is 2, and value of n is 1100111, and which is equal to 103 in decimal. Students, when we will put these values in the equation of ones complement, we'll get 2 raised to the power 7 minus 1 minus 1100111. And students, in the next step, it will become 128 minus 1 minus 103, and after simplification we'll get 24, and when we will convert 24 into binary, we'll get 001100. Students, you can see that we have added two zeros at the left hand side. We have done this so that the number of digits in the question and number of digits in the answer remains same. Students, we can also check the answer with the help of shortcut. In the shortcut, we know that to find ones complement, we change 1 into zeros and 0 into ones. So in this case, we have changed ones into zeros and 0 into ones, so we'll get 0001100. Students, similarly you can find the twos complement. Twos complement is ones complement plus 1, and the formula is r raised to the power n minus capital N. And so when we will put these values in the equation, we'll get 2 raised to the power 7 minus 1100111, and after simplification we'll get 128 minus 103, and which will result into 25, and after changing 25 into binary we'll get 0011001. You can also find the twos complement with the help of shortcut. In shortcut, we know that we keep the first rightmost one as it is, and we change rest of the ones into zeros and zeros into ones. So in this case we'll get 1001100. Students, I think you have understood the concept of complements, and try to solve a few more questions on your own. I will also give you some questions in the assignment. Students, this is the end of lecture number 5 of computer system architecture. Thank you for attending this lecture. See you in the next lecture.